Okay, this is an RC circuit problem. The capacitor is uncharged in the beginning, and then at t equals 0 we close the switch. They want us to find the current through resistor 1 at t equals 0 at the instant we close the switch. Then they want us to find the current through resistor 1 a long time after the switch was closed. Then they want us to find the voltage through the capacitor a long time after the switch was closed. And finally, the current through the capacitor at 1.5 seconds after we open the switch. So this process happens after these. So we wait a long time and then the switch is opened, and we're gonna draw a new circuit and calculate the current after this time. Okay, let's get to it. Okay, at t equals 0 our capacitor is uncharged, therefore we know that the voltage on it, voltage on the capacitor, is 0. Now in parallel the voltage is the same. Since the voltage is here 0, then on this resistor will be also 0. We can voltage on resistor 2 will be also 0 volts. This is volts. Now, because we know these, let's do a quick loop rule. We're gonna go around this way. Positive EMF, we're gonna go clockwise. Positive EMF, voltage drop on resistor 1 minus voltage drop on resistor 2 equals 0. This one we know it's 0, therefore voltage on resistor 1 will be equal to the EMF on V1 equals, this is 20, it's given, therefore we're gonna get a value of 20 for V equals 1. From here we can use VIR, and from here we're gonna solve for I equals V over R, and this gonna be current in 1, voltage on resistor 1, and this is the resistance of resistor 1. Let's plug in V1, we just found it, 20 volts, resistance is given 2.00 times 10 to the 5th ohms, and this, if we calculate it, it's gonna give us a value of 1.0 times 10 to the -4 amps. That's our answer for part A. Okay, now in part B they want us to find the current through the same resistor, resistor 1, but now a long time after the switch was closed. Now our capacitor is fully charged, and when the capacitor is full there's no current going through it, so we can make a note of that. Current to the capacitor is 0. Now, since there's no current flowing this way, the current is coming from EMF this way, and over here there's no more current coming this way, so that means everything that's coming here needs to go this way. So therefore current on resistor 1 will equal to the current on resistor 2. So current 1 equals to current 2. Now again, let's do a loop rule in the same area where we did before, plus the EMF, voltage drop on resistor 1, but this time we're gonna write it with the help of VIR, So current, as we know 1 and 2 equals, I'm just gonna write it as I times R1 minus voltage drop on resistor 2. But again, I'm gonna use this one, same I times R2. There's nothing else left, so equals 0. Now we're gonna solve for I. EMF minus I R1 plus R2 equals 0. From here, I equals EMF R1 plus R2. We're gonna plug in the values. 20 volt divided by 2.00 times 10 to the 5th ohms plus 5.00 times 10 to the 5th ohms. If we calculate this, the current that we're gonna get will be 2.86 times 10 to the negative 5th amps. And there you go. This will be our value for part B. Okay, voltage on the capacitor a long time after the switch was closed. Here we're gonna use the fact that in parallel the voltage is the same. Therefore, whatever voltage we're gonna have on the capacitor, same voltage will be on the resistor number 2. Let's write it down. Voltage on capacitor is equal to voltage on resistor 2. And with the help of VIR, we can say that voltage on the capacitor will equal IR, but R will be our R number 2. So VC will equal our I, we just found it, 2.86 times 10 to the negative 5th amps times 5.00 10 to the 5th ohms, and if we calculate this, will give us 14.3 volts. And there you go. Now the last step, after a long time, after all this happened, now we're gonna open the switch, and they are asking us to find the current on the capacitor after 1.5 seconds passed after opening the switch. Okay, this is the formula that we're gonna use, but here we're gonna use VIR again, and we're gonna plug in, instead of I naught, we're gonna use the form where we plug this in and E over R. So I'm gonna write down straight this one. I equals the EMF over R times E to the negative T over RC. Okay, and before we start looking at our numbers, let's see what, after we open the switch, what do we have left. When we open this switch, all this part will disappear. The only thing we will have left is this little loop right here. So our circuit will look like this. Is our R2. Come back down. This is our capacitor. And back to the resistor. This is all we have. And up here, since our battery is plus minus this way, the current was flowing in this direction. Therefore, the capacitor was charged plus minus in this manner. Let's mark that down here too, plus minus. Therefore our current down here will flow, when the switch is open, will flow this way. Okay. Now that we know what's left in our circuit, it's gonna be much easier to fill out our numbers here. So I equals our voltage that we have here. We calculated it, it's right here, 14.3 volts. On the bottom R, only R left in our circuit is R2, so we're gonna write 5.00 times 10 to the 5th ohms times E on the negative T. Our T is the time that they're asking, 1.50 seconds. And on the bottom we have RC. R again is the same, this R, so 5.00 times 10 to the 5th ohms times our capacitance. Capacitance is 5 microfarads. So 5 instead of micro, we're going to write 10 to the negative 6th and farads. If we calculate this, we will get a value of 1.57 times 10 to the negative 5th amps. Alrighty, that would be it.